The next theorem that we're going to take a look at is again about convergent sequences. So if we have S sub n and T sub n are two different convergent sequences, with the S sub n sequence converging to S and the T sub n sequence converging to T, if the terms in the S sub n sequence, if they are all less than the corresponding term of the T sub n sequence, then the value that S sub n converges to must be less than or equal to the value that the T sub n converges to, right? So S is less than or equal to T, right? And so we are going to prove this. And our method of proof that we are going to use is we are going to use a proof by contradiction. So let's suppose that S is actually bigger than T. What? Then let's take epsilon to be equal to S minus T over 2. Which, since S is bigger than T, that value should be bigger than 0, right? So that is an appropriate value of epsilon, a value of epsilon that we could choose. With this, we would then have we have 2 times epsilon is equal to S minus T. And T plus epsilon equals S minus epsilon. All right, so we can add T to one side and subtract one of those epsilons to the other side. All right, so T plus epsilon is equal to S minus epsilon. Since we have S sub n converging to S, there exists some value n1 such that as long as n is larger or at least n1, we have the absolute value of our sequence minus S should be less than epsilon, which is to say that the value of S sub n is somewhere between S minus epsilon and S plus epsilon, right? So our value of S sub n here has to be within epsilon units of S, right? So that's what that's saying there. Similarly, T sub n goes to T, so there exists some n2 such that whenever we have n bigger than n2, this implies that T sub n minus T is also less than epsilon. Right, so that T minus epsilon is less than T sub n is less than T plus epsilon. And those, again, are true for every choice of epsilon. So let's let n be the maximum of those two choices, n1 and n2. Then if we have any value that is larger than that, we get T sub n is less than T plus epsilon. But we established earlier, way up here, that T plus epsilon was actually equal to S minus epsilon. And that should be less than, we established right here, that should be less than S sub n. And so there's our contradiction. We suppose that S was greater than T, while also still maintaining S sub n being less than or equal to T. That's part of our given, and so we just contradicted the given equation or the given information. Right? And so we have our contradiction, and our theorem is proved. This is a contradiction. Therefore, it's not true that S is greater than T. In fact, S must be less than or equal to T, right? By trichotomy. Right? As a corollary to that, we could say that if T sub n converges to T, and that value of T sub n is greater than or equal to 0 for every single choice of n, then whatever value it's converging to has to be greater than or equal to 0, right? And so we're just replacing in the previous theorem the sequence S sub n with a sequence of all zeros. That sequence of all zeros converges to 0, and so whatever T sub n converges to has to be bigger than 0. All right, I will see you in our next video.